Can we make computer programs that codify human knowledge? That's the domain of expert systems, a subdiscipline of AI, the topic of today's episode. Welcome to Kopec Explains Software, the podcast where we make computing intelligible. This week we're talking about expert systems, once a thriving subdiscipline within AI, a subdiscipline that still exists but doesn't quite have the excitement that it once did. I want to mention that a lot of today's episode on expert systems comes from Chapter 9 of the second edition of Artificial Intelligence in the 21st Century, a book by my late father, Danny Kopec, and Stephen Lucci. And my dad actually wrote this chapter, so thanks to my dad for the knowledge on expert systems.
So expert systems were the cutting edge, once a really big deal in AI, but not so much anymore. What happened?
Yeah, a lot of the excitement in AI today is around machine learning. And we did a previous episode that went over the whole topic of artificial intelligence, which is such a big topic that you can't really go over it in one episode. But we talked about what the various subdisciplines are, and I'm going to link to that in the show notes. But artificial intelligence has many different subdisciplines within it. Expert systems are just one of those many subdisciplines, and they're not actually like a super popular subdiscipline right now. If you were learning AI in the 1980s, expert systems were at that point seen as very successful, and they were kind of the pinnacle of AI that led to a lot of AI funding and research. However, there was what was called the AI winter, which came about in the late 80s through to the 90s, when all this built-up excitement about expert systems didn't pan out in as many applications as people thought it would, and then a lot of the funding dried up until the 2010s when deep learning and advanced machine learning really brought AI back. So today, a lot of the excitement in AI is around machine learning, but if you were learning AI back in the 1980s, it would have all been about expert systems.
Well, what makes up an expert system?
An expert system typically has two main components, a knowledge base and an inference engine. The knowledge base is a way of machine codifying human rules, human heuristics, human knowledge. It's basically a database of human rules about how to solve some kind of problem. And then the inference engine is able to process the rules in the database and use them to give you some kind of answer to some kind of problem. Is it always going to give you a great answer? No, but we're going to talk about some of the properties of expert systems that still make them valuable, even if they can't give you always a perfect answer.
So a person has to give it the base of knowledge, and then it's able to answer questions?
Yeah, pretty much. I mean, so there have to be at least two different practitioners that work on an expert system. Typically, there'll be a programmer, obviously, but then the other person who works on an expert system or multiple people is typically a domain expert, somebody who has a deep knowledge of the type of problem that's trying to be solved. Let me give you an example. If you're trying to solve a medical problem, the domain expert might be a medical researcher or a doctor. Somebody who actually has the knowledge that the program is going to need to solve the problem. This is different from a lot of modern machine learning systems, which learn based on examples. They're provided examples, trained, and then able to infer how to solve a particular problem without hard codifying specific rules. However, in an expert system, it's all about taking rules that humans already know. Like, we already know some heuristics to use to figure out what kind of disease somebody might have. We know what symptoms to look for. We know what other diseases the disease might be associated with. And the domain expert who works on an expert system is responsible for taking all of those rules that are in their head and in the literature and converting them into simple rules that can be codified inside the knowledge base.
So that would be like an if-then sort of statement?
That's right. For those of you that are familiar with programming, the kind of funny thing and kind of the way sometimes expert systems are put down almost a little bit is that what it really boils down to, the combination of the inference engine and the knowledge base, is like a lot of if-else statements, if-then statements, saying if this thing is true, then we go down this path in the expert system and ask you this other question and go to the next level and the next level based on intuition about what are the right questions to ask and what are the right levels to go to based on the answers to those questions that come from some human domain expert.
There are real challenges with relying on human expertise and limitations to that for expert systems, right?
Yes, an expert system is only going to be as good as the knowledge coming from the human domain expert that produces the system. And another big problem is what's called knowledge acquisition, which is how do we take the knowledge that the human has and codify it? Sometimes humans work by intuition. It really depends on the domain, but some domains are very intuitive for humans, and it's hard for them to actually express how they solve the problem. And so this is actually one of the hardest parts of an expert system, is how do we actually take the human knowledge and codify it into machine knowledge, into machine rules?
If we think about the way a human expert in some kind of domain is, there's a few different components of that and of their knowledge base, right? They're able to solve a problem, and that's what makes them an expert. They can solve a problem in their area, right? They can explain how they solved a problem. They can learn, and this is just one of those really interesting things, right? How do humans really learn is a little bit of a mystery still, or a lot of bit of a mystery. They can restructure their knowledge. So a human expert can recognize where their knowledge can be applied, even if the environment or the system that they're working in has changed a little bit. And I think one of my favorites of human experts, right, is they know when to break the rules. We all know that saying, the exception that proves the rule, right? That's the saying. And that's a really important component both of human knowledge and of a domain expert. And a human, hopefully, should know their limitations. A real expert knows what they don't know, or knows there is a lot that they don't know. And perhaps most importantly, when really comparing to a computer, is that humans degrade gracefully, right? A computer that stops working shuts down, which is a pretty big problem in an expert system.
Or at least needs to be codified in a careful way so that it doesn't just crash or shut down when an error occurs or when it's beyond its limits. So, these 7 characteristics that you went over about humans are one of the things that make human experts often a lot better than machine experts. And again, with expert systems, it's a big challenge to apply all of these characteristics to them. One that I think is really important for expert systems is the idea of explaining the result, because it's one that really distinguishes expert systems from more modern AI techniques in the realm of machine learning. When you throw a neural network at a problem, for example, it's often a black box. We don't really know how the neural network came about to approximate the function and solve the problem. We can go and try to look through the weights of each of the neurons, but it's kind of a mess and it's not easily readable for a human being who's working with it. This is very different from an expert system. Because an expert system has codified rules that came from a human expert, it can actually walk you through what rules it applied, what were those if-else statements that it went through in order to give you the solution to a problem. So this is one of the big advantages of expert systems over more modern AI techniques.
One of the things that's important for an expert system, or I guess any kind of software you're developing, is knowing when to apply it. When does an expert system make sense to be used? And I think this is something that I found pretty interesting, is some questions that a programmer might ask themselves before they maybe dive into developing an expert system.
So the first is, can the problem be solved efficiently by conventional programming? If there's an existing algorithm that can solve a problem, there's no reason to use an expert system. Another one is the domain well-bounded? Expert systems have to have these knowledge bases built up from human expertise, and so they have to be applied within a limited domain, because we can't just have an expert system that knows about everything in the world or even about areas that it doesn't have knowledge from a specific domain expert in. And so
there's no person that knows everything about everything.
Right, exactly. And the way that you would codify the rules for an expert system in one domain is going to be quite different than you would for another domain. And so they only work well in domains that are well-bounded. This one might sound kind of weird, but you also need to actually have a cooperative human expert to make an expert system, and that can actually be a real limiting factor. believe it or not, there are some industries where people don't want to be replaced by a computer program, and they're actually reluctant to share their knowledge, professionals in that field, or they're not capable of, because some human expertise, like we talked about earlier, is very much based on intuition. So it's hard to even codify the human's expertise. So as you can see, not every problem can actually be built into an expert system. And also, it's very laborious actually going and creating all of those rules in the knowledge base. And so it takes quite a bit of programmer hours and domain expert hours to create an expert system. And the bigger the domain area, the more laborious it is to create that expert system.
There have been some really important and successful applications of expert systems, though.
That's right. Probably one of the most famous is Mycin. And that's MYCIN for those of you that want to look it up. But it was actually a expert system for determining blood diseases and both trying to figure out what blood disease somebody has and what therapy should be applied for that disease. And it was actually used in the real world. There's been a lot of academic expert systems, but Mycin was one of the first successful ones to be applied in the real world. And that was in the late 1970s.
Then there's also ones around like prospecting, so mining, where it gets used a lot, or has been used a lot.
Yeah, Prospector is an expert system that tries to codify the heuristics that expert human prospectors, there's where the name comes from, use for figuring out where is there going to be a nice vein. So I'm looking for some, diamonds or something, but I don't think it was actually used for diamonds, but I'm looking for some vein of some valuable mineral. And based on the characteristics of the area around where I'm looking, is this a good place to dig? Well, humans can get very good at that, who've been in the industry for a long time. And actually, the Prospector system was pretty good at it too. So that was an area where they were successfully able to take human knowledge and codify it in an expert system.
And then a more recent example has to do with oil slicks.
Yes. So a lot of these examples that you can read about, if you go look up the literature on expert systems, are from when expert systems were at the height of their hype cycle in the 70s and the 80s. But I found this one interesting because it's really quite recent. There was the big BP oil spill in the late 00s, and there had to be ways of figuring out where is the oil in the Gulf of Mexico that we need to clean up. And there was an expert system developed right after the oil spill that was able to actually successfully go look at an image of some area of water and determine, this is probably, again, based on human heuristics that have been codified, an oil slick. So probably a place that we actually need to clean up and not just a place that has randomly dark water because of other things under the ocean or the light that day.
So all of these are ones that are like very practical and applications that got really well utilized.
Yeah, and I think that's one of the interesting things about expert systems is that they were this very successful part of AI, and there are some that are very successful that are still being used, but they're not part of this current hype cycle of AI at all. I don't even want to call it a hype cycle because the current techniques in machine learning are amazing and are creating incredible applications. But expert systems are still a very viable technique that exists. They might sound to current people who study AI almost simplistic and almost so basic, but they work, and they have been proven to work successfully in many different areas. And reading that chapter in my dad's textbook, I think one of the things you really come across is how important they were for the history of AI. If they hadn't come about, it feels like there would have been almost no progress in AI in the 70s and 80s because we weren't yet at the point where computational power was significant enough to do advanced machine learning. And so it kind of kept AI afloat in the 70s and 80s. And I think sometimes there might be some characteristics of them that would even be great to have today that we don't get from machine learning systems. And the number one is the one I explained earlier, which is that idea of being able to explain your answer. I mean, if you get a medical diagnosis from a neural network and you don't know why it's giving you that medical diagnosis, you rightly might be a little bit skeptical. But if you get a medical diagnosis from an expert system and it walks you through, here's the 10 rules I went through, the 10 if-else statements that led to this diagnosis, you're much more likely to trust that outcome. So I think that transparency about where the answers come from can make people more comfortable with the computing system. And so I think there's still a place for expert systems today, maybe more than they actually get. One other little area of expert systems that we didn't talk about that's also interesting is called case-based reasoning. These are expert systems where the rules are based on previous situations that are similar to the situation of the current problem, instead of just trying to figure out, like, kind of forward-looking how to figure out what the solution is. It's more backward-looking, looking at similar problems from the past and similar situations from the past. It's not the same as being trained on the previous situations. It's more like trying to match to the previous situations. So one example that's given in the book is about baseball. So you could build a case-based reasoning for what kind of play you should do in baseball. For example, when you have runners on first and second and you're up at bat and there's no outs, often, or maybe there's one out, oftentimes it makes sense to bunt. So an expert system based on case-based reasoning would know, in previous situations with runners on first and second and a batter with such and such characteristics who's reasonable at bunting, you should go for doing the bunt. It's not actually looking at
how many times someone has bunted in that situation over the course of the history of baseball.
Right. It's not doing it statistically. It's instead looking at, this is a situation that human beings have codified as being similar to the situation you're in right now, and this is what you should do based on human knowledge. So that's why it's an expert system and not a machine learning system that's just going and statistically looking at every previous situation where anyone's ever been in the same situation.
What I find really interesting, or what I kind of like about expert systems, is that it's this place where software developers are really partnering and combining with a real person who's an expert in a different kind of area. And it really speaks to this way that maybe it was the start of software being really able to solve problems and answer questions within the world.
Yeah, I think right now there's too much sometimes of an attitude of the programmer's just going to solve all the problems in the world without working with the people who've already been trying to solve those problems for so long. And I think you're right. What's really emphasized in the book about expert systems is that expert systems are a partnership between a programmer and a domain expert, and that domain expert is not a programmer. All right, thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
Don't forget to rate us on your podcast player of choice, and we'll see you in 2 weeks.
Bye.